Good morning everyone, I'm Chris, the sun is out, and welcome back to another episode of Rift Amps.
Right, so bad news, well maybe not. We've got a warranty repair come back in. This is an Americana LP, and now I think it's important with any channel like this that you show when things don't go right as well as when they do go right. It's important to show both sides of the coin. So this has come in under warranty. Backstory is customer has been playing it for a couple of months, absolutely fine. He said he was abusing it quite heavily with a fuzz pedal, and it started to make a really awful sound. Okay, so my first thought was, maybe he's blown the speaker, but no, it's not that, and I'll show you what we found. In fact, it's probably not related to his fuzz pedal at all. So tap the amplifier. I can hear a couple of crackles and things. But if I turn the reverb control up, something's clearly not happy. Now, a lot of people ask why I do my twists over the top, okay? Now that's because on the underside of the board, I only want there to be ground connections, all right? Or at least connections that I know where they go to, so I never have to double check anything. So clearly we've got a cold solder joint here. A joint's gone bad and it's causing noise. We've just got to find it. I know that if any of the wires underneath the board, have fallen out or come loose, it'll only be a ground wire, so we're never risking a short to the chassis. All right, so it's exactly why I do that. And if it's one of these overboard wires, well, it's easy to fix. So that's where we are. So I'm going to go through this, find out exactly where that issue is. Very interesting. I wasn't expecting that noise to be so aggressive. But, that's what warranties are for. Warranties aren't there to say the amp will never go wrong. Warranties are there to say, if it does go wrong, I'm going to look after you and I'm going to sort it. So, there we go. Americana LP, in for some dodgy noises. Let's get it sorted. Right, so that's the Ainsley Lister signature off to California. All boxed up, ready to go. Someone asked, why do I wrap these in pallet wrap? I'm not sure if I've mentioned this before, but we had an incident during COVID. During that time where I sent an amp to North America, and because of delays at the airport, at the cargo hub, one of the amps sat outside for 2 weeks in the rain, right? And eventually, we got the amp returned to us, and the box was just destroyed, and there was no way that amp was going to complete its journey. And so since then, I've decided actually, just the cardboard box is not enough protection. We also need some weather protection. So I just put this pallet wrap around it just to make sure that if at any point, while the amplifier is outside and it's raining, it's just that extra level of protection. So we learnt that one the hard way. But ideally, if I didn't have to use the extra plastic, I wouldn't. But it's a £4,000 amplifier. I'm going to do everything I can. Just working on another Elysium. I've got my pot, switch, jack and power supply loaded, so I'm just starting on the wiring, getting things done on that. Had a really good question, or comment I should say, on the on a video where I mentioned that I was putting in the description of the videos all of the gear I use, because a lot of people ask what it is that I'm what I use in the workshop and things like that. And he said there's lots, and he said as for the oscilloscope, he would go for the new Siglent SDS 804X for about the same money as the one that I use. Cool, maybe, yeah, go for it. With guitar amplifier stuff, you don't really need a top of the line mega oscilloscope. Up to 20 megahertz is fine, and the one I use I think is 70 megahertz, so it's way over spec for guitar stuff anyway. And most of the time, all you're using it for is just for, you know, following your signal trace through the circuit and things like that. So it doesn't have to be I mean, you could get away with, you know, a really, really cheap one, and for most audio work, especially guitar stuff, it's absolutely fine, not an issue. But what I always say to people is buy the best thing that you can afford, but more importantly is learn how to use it, right? So there's no point buying, you know, a super top of the line expensive oscilloscope if you don't know how to use it. Same with signal generators, or function generators, spectrum analyzers, bits like that. Learn to use the equipment. Understand the oscilloscope that is, you know, a relatively modest oscilloscope already has most of the functions and is far more powerful than you'll ever need. So there's no need to go over the top as long as you learn to use it. So that's that one. But yeah, I mean, if you find a good deal on something, why not pick it up? But I can only recommend what I know, and I've been using that scope for a couple of years now. I really like it. Does everything I want it to, and every time I switch it on, it works. What more can you ask for? And the Matamp is finally done. All buttoned up, all put back together. Just need to remove, just give this faceplate a bit of a clean, because it's got some smudges and finger marks and things on. But apart from that, it works, it sounds great. Now, do you remember I said there was a slight bit of noise in the preamp? Well, all three of the Novel valves, all of the pins were quite corroded and dirty. So I've given them all a clean, put them back in, but one of them hasn't quite cleaned up enough. However, it has now gone quiet. So what I've said to the customer is just get yourself a spare, and if it does start to go noisy, you can just plug it. It's plug and play, so it's easy enough to do, and that's fine. Easy enough. Apart from that, everything works as intended. Sounds great. Reverb does its thing. Everything's fine. It's quite. I mean, it is a loud amp. You know, it's not a quiet beast, but the master volume is surprisingly effective. You know, you get a really good tone at quite low down on the dial, which you know, it is a sign of a really well designed circuit. So there you go. Anyway, it's been really cool having this one in. I've really enjoyed it. You know, obviously thanks to Hayden at Matamp for all his support with this, especially when you've got an amp that was from a period when they didn't keep very good records. You know, a lot of this stuff was custom ordered, so you know, one amp was different to the next. This particular one, we know, the bias board and the bias supply was for EL34s, not the 6V6s, which it's running and which the rear faceplate says it should have. So that's where our main issues were. But it's now running. It puts out exactly what it should do. It sounds great. Again, just a really cool old boutique British amplifier. And the owner, oh yeah, that was the other thing. I've sent the owner the bill, and he said stick another hour's labour on it, because he's really, you know, he knows it took me longer than what I charged him for, but a lot of that wasn't my fault. It was, you know, down to learning. But he's, you know, he's offered to pay an extra hour. So yeah, thank you very much. I really appreciate that. Got some good customers, a great amp, and we'll sign this one off. Right, so back on with the Cornford Hellcat. Now this is the rewind a bit. Custom brought this in for a number of issues. The first one, he says that the second channel fluctuates in gain relative to the first channel. There's a weird oscillation going on in the mid-range, and also he said, oh yeah, the EQ feels rather weak. So anyway, we remember we gave this thing a visual inspection. We went through it. We couldn't see anything immediately obvious, apart from on the oscilloscope, the bias looked pretty bad. Definitely some crossover distortion there. And so what I've been doing this afternoon is working on this. There's no point trying to fix anything in the preamp unless your output stage is working as it should be. Okay, so the first thing I did was took some bias measurements as the amplifier was. Okay, so here's our 4 EL84s, V6, V7, V8 and V9. So as you know, when you're taking bias measurements you're measuring on the valves, you're always measuring in respect of the cathode. So incredibly, our anode to cathode voltage anode to cathode, across all 4 valves was 381 volts. Okay. Then measuring across the cathode resistor, and it's a single resistor shared by all 4 valves. So voltage cathode to ground, 12.15 volts. The value of the resistor, which is this one here, is 100 ohms, but when you measure it, it's 97.7. So a little bit of Ohm's law, V equals IR. We need to know the cathode current. I is current, so current at the cathode. So all the current flowing through that resistor will be voltage divided by resistance. 12.15 volts divided by 97.7 means there is 124.3 milliamps flowing through that resistor. Okay. Now there's 4 valves, so we divide that number by 4, which means we get roughly 31 milliamps each. 31 milliamps times by the anode to cathode voltage gives us 11.845 watts of dissipation. Now, because we're using the cathode current, that is the anode and the screen grid combined, okay? And I would expect that to be slightly over 12 watts, 12.5, 13 watts. Where I'd like it to be. We calculate that to be 98%. Okay, the maximum anode dissipation or plate dissipation for an EL84 is 12 watts, and then you're also allowed 2 watts for the screen grid, so 14 watts in total. But again, that's running it very hard. But with those bias measurements, we had quite a bit of crossover distortion. And I'll put that on the screen now and you can see how that looks. Okay, so the valves aren't quite running hot enough. They're not conducting enough of the sine wave to get a clean output. So we need to increase the amount of current running through each valve, currently at 31 milliamps. And the way we do that in a cathode bias amplifier is to reduce the value of the resistor, which is a 100 ohm resistor, currently measuring 97.7. Well, the next value down in the E12 scale is 82 ohms. Down from 100, the next one down is 82 ohms. Okay. So what I did was I removed the 100 ohm resistor and the bypass capacitor here, which is a 100 microfarad 63 volt. Now, interestingly, I've tested this and it is slightly leaky. So I fitted an 82 ohm resistor from my stash and a new capacitor. And here are the numbers. First things we notice, we compare it to the old numbers, put them side by side, is our anode to cathode voltage has now dropped from 381 to 378. Now, why is it dropped? Well, as current increases, voltage decreases, and as current decreases, voltage increases. So we're running more current through the valve, so I would expect to see a drop, and we've dropped roughly 3 volts there. Okay, our voltage across the new cathode resistor is 11.2 volts. Again, current increases, voltage decreases. The value of the new cathode resistor, even though it's labelled as 82, is 80.5 ohms. And out of all the ones I've got, that was the closest I could get. That means now our total amount of current running through that cathode resistor has gone up from 124.3 milliamps to 139. Which means you've now got 34.8 milliamps each. So call it 35. That's roughly 4 milliamps extra running through each valve. Okay, which now puts our combined anode and screen grid dissipation to 13.14 volts. Okay, Now, as I said, we're allowed 12 watts for the anodes and 2 watts for the screens. So on the amplifier itself, you can see there are screen grid resistors. There they are, 100 ohms on each socket. And so we can use those, just like we do with the cathode resistor, to calculate the amount of screen current and therefore screen dissipation. So the voltage across the resistor, 0.311 volts. The value of the resistor, 98.8 ohms. The voltage from the screen grid to cathode, remember it's always in reference to the cathode, 288 volts. Means we've got roughly 3 milliamps of screen grid current. We times that by the voltage and we get 0.9 watts. So the screens are running at just under 1 watt. So we take our 13.15 total, minus 0.9 means our anodes are at 12.24, or roughly 102%. So they are ever so slightly on the hot side, ever so slightly, but we know EL84s are very robust. Now, interestingly, what has that done to our output sine wave? Well, at the same rated output, 14.4 volts, I'll put it on the screen, but you can see it here as well, that crossover distortion has vastly reduced. We've now switched the valves on to a point where they're operating and producing a much nicer sine wave. So now we've made the output of this amplifier a lot cleaner, and that should help us then further diagnose the rest of the the rest of the issues in it. Now, one more calculation we need to do. The original resistor, cathode resistor, was a 7-watter. Now, the general rule of thumb is that you double rate. So we can calculate what we need for this one. Watts, this is Joule's law, watts is voltage times current. So the voltage drop across the resistor was 12.15. Times that by the total current running through it in amps, so we need to go 0.1243. Gives us a total of 1.5 watts. So if you double rate that, we go up to 3 watts. And they've used a 7, so they've more than double rated. And that's a nice cement resistor there. Okay. Now, I didn't have any 7-watt resistors for the 82 ohms. I only had 5-watt resistors. So let's do our sums again on this side and see what we end up with. So watts is voltage times current, so 11.2 volts times by 0.139 amps, 1.55 watts, double rate that times by 2, 3.11 watts, and we've used a 5-watt resistor in there. So actually, if I say 5 divided by 1.55, we've over triple rated that resistor. So that one's got more than enough grunt in there. Okay, nice sine wave. Looking good, right? So I'm just going to let this burn in, soak in, retake the measurements again in about an hour, and then I can come back and I can see where to go from here. Right, Dexter news. The amp is up and running on the bench. Faceplate has arrived, which meant I was able to fit the on-off toggle switch, get all that wired in, get the amp finished off, which is now running on the oscilloscope. Output sine wave looks great. Done all my voltage checks, my bias checks. I've gone through it. I've given it a play test, and I am, I'll be honest with you, 98% happy with it at the moment. Couple more little things I want to do to tweak it and adjust it and get it exactly where it needs to be. So almost done with this. Then we can get the thing boxed up and shipped off. So yeah, good news on the what is it? It's a Dexter. Yeah, good news on the Dexter.
Well, that's it then, guys. Thank you very much for watching once again. I just had a look and I'm nearly at 3,000 subscribers, which is just mind blown. I can't believe it. I can't believe we're so close. I would absolutely love to get this channel to 3,000 subscribers before the end of the month, or by the end of the month. If you could all do that, that would be great. Looking at the stats, roughly only 1/3 of you who watch this channel are actually subscribers. So, you know, there's 66% of you who tune in haven't clicked that subscribe button yet. So hit that button, thumbs up, all the comments down below. Join the channel if you want to. You know, that's a great way to help me out. You'll get access to these videos early, amongst some other things. And I shall catch you all at the next one.